Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Doublarr by Ichtues. I think that's how you pronounce it, or it's Ichtues. Ichtues? Like, I don't know, I'm not sure if it's German for I, whatever Tues is, which could be like a shorthand for Tuesday? I don't even know. Anyways, enough on the name of the setter. Here are the rules. Normal Sudoku rules apply, which means fill every row, column, and box with the digits 1 through 9 without repeats. Then we also have arrows, where values along an arrow sum to the value of the attached circle. So basically, as an example, the values along the arrow sum to the value of the attached circle. Excuse me. So for example, if the value of this digit were, say, a 5, and the value of this digit were, say, a 7, the value of this circle must be 12. And this is important because of what's to come. We also, in this puzzle, have doublers, where 9 cells in the grid, 1 per row, column, and box, are doublers, which count as double their value. So if you have, say we had this combination of this being 5 and 7, well, this could be a 6 doubled, because 6 doubled in value is 12, and that adds up to the values of 5 and 7. So that's how you could potentially get a 5 and a 7 adding up on an arrow to a 6. And each digit appears in exactly one doubler. So that means there are no repeats in the doubler cells too. So that's also the digits 1 through 9 through in all the doubler cells. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, so the one thing that I noticed is we have 5 cells in here. Actually, it's... Okay, there's 4 boxes in here, in this grid, where we have 6 digits in the box add up to 3 digits in the remaining arrows, right? These are 2, 2, and 2. That's 6, adding up to those 3. This is these 6 adding up to those 3. Now, what does that mean? First, it means the values in that box must be double. Must be times 2, right? Sorry, it has to be an even value. So that means an odd digit must be doubled here. Because these digits add up to essentially what these 3 digits are, right? So this must be essentially double the value of, the whole box must be double the value of these 3 cells. Same here, the box must be double these 3 cells. Therefore, the doubler in each of these 4 boxes must be odd. What does that tell us? I'm not really sure, but it does tell us something. So, what about this box? This box is a little different, because this arrow equals the same as this. This arrow is the same as this. And this arrow is the same as that. So these are equal to 3 times this value, and this is equal to 2 times that. So this does not have to be odd here. Okay. What other do we have? For these three to be essentially, sorry, for these 4 boxes to essentially have the doubler and the arrow, that means the doubler has to be a 1 or 3 because you need to add up to 24 at most because you have the most 7, 8, and 9. You have 45 already. If you double 1, that gives you 46, and you divide by 2, that's 23. So that would work. If you have 45 plus 3, that gives you 48, and you divide that by 2, that's 24, and that would work. So it's possible for the doublers in these cages to be 1 and 3 here. The other ones have to mean the doublers have to be in the circles because you can only have 1 and 3 in a doubler once. So the rest of them have to be either 5 doubled, 7 doubled, or 9 doubled. Oh, okay, well, there you go. That makes sense. Okay, you cannot have 9 doubled in any of these circles. It can't. 9 doubled obviously doesn't work as an arrow because there's no way that 18 will add up to a single digit with another digit. And if you have 18 as the double digit here, well, what 2 digits without doubling add up to it? Nothing. So therefore, these doublers have to contain 1, 3, 5, and 7. Interesting. So there has to be a 1 doubled somewhere. So this is 1, 3, 5, 7, and 1, 3, 5, 7 doubled, right? We know all of these are 1, 3, 5, 7 doubled in these cells. Because 9 doubled doesn't apply anywhere in any of the arrows or the circles. So one of these has to be 6, 8, and 9, and one of them has to be 7, 8, 9 as the for the 1 and 3 doublers, right? Can 1 and 3 be in the circles doubled? I don't think so. Oh, 3 could be actually in the... Hmm. Three actually could be as one of the doubles. It could be in one of the circles, right? Because 3 doubled is 6. And 6, 8, and... Oh, no, that doesn't work. It has to be 24. So, no. None of the 1, 3 doubles can be in any of the circles. They have to be in the arrows. Excuse me. Okay, so what does that mean then? Well, we need a 5 doubled and a 7 doubled. Um, And they both have to be in circles, obviously, because they can't add up to a non-doubled value. So the question is, where are the 1 and the 3 that are being doubled, and what are the 5 and the 7 that are being doubled? Okay, so the 5 doubled, that means you have the values adding up to 50 in the box. So it has to be 25, right? So 25 minus 10 is 15. So it'd have to be either 6, 9 or 7, 8 in these circles. So far we have 7, 8, 9, or we have 6, 8, 9 in the 1 doubled box. We have 7, 8, 9 in the 3 doubled boxes in the circles. And we have 5, 6, 9 or 5, 7, 8 in the 5 doubled circle, or the 5 doubled box. What about the 7 doubled box? 7 doubled would mean 45 plus 7, which is 52. So it's 26. 26 minus 4. Sorry, 26 minus 14 is 12. So it would be 3, 9 or 4, 8 in that box for the arrows, right? Because you have 7 doubled already, and then the other 2 digits must add up to 12. And so you cannot have 5, 7 anymore, so it's either 3, 9 or 4, 8. So you always have an 8 or 9 or both in the circled cells. So all of these circled cells are 3 through 9 then. This is 3 through 9. And this is 3 through 9. Right? One of these is 8 or 9, at least. So if this were 3 through 9, that means 8 and 9. Okay, sorry. If this were 3, that would mean this would have to be 9 and 7 here. Is that possible? Hmm. Hmm. You can't have 4. In the 7 doubled case, if you have 4 and 8, how does that work? The 4 would have to have values of 1 and 3 with it. I guess that could work, right? 4, 1, and 3. This 8 would be 2 and 6. The 7 doubled would be 5 and 9. So that's possible. Okay, so that is possible. Okay, so this cannot be 9 here. Right? Sorry, it cannot be 9 doubled here. If this is 9 doubled, the problem with that is these are 2 length arrows each, right? And if you have a 9 doubled, obviously can't be on the arrow because 18 doesn't sum up with another digit to add up to a single digit that's not doubled. And if you have 18 doubled, again, this cannot be actually, and this can't be 9 either doubled, right? Because of the same problem. Because if you have 9 doubled, you have to have this is either 2 digits and this is 2 digits adding up to 18, which is not possible, or 18 has to be on the arrow, which adds up to a single digit, which is not possible. So this cannot be 9 doubled. This cannot be 9 doubled. So the 9 doubled has to be in one of these boxes here. One of these lower, the middle box or the box 8 or box 9. So this has to be an even digit. This has to be an even digit that's doubled, which means this is an even value because this is essentially the same as this, which is 2 times something, 2 times this value. This is 3 times this value, and it has 1, 2, 3. Well, the value can be higher. But this has to be triple. So since there's an even digit that's doubled here, that means the whole total must be odd because it's 45 plus another even digit, which is odd. Therefore, this is an even value. This has to be an odd value then, which means this is 3 times. So this is essentially one of the circles in value. This is the circle in value, so that's 2 times that. And if this is an even value, it would be 3 times that, which is not allowed. Or it would be 3 times an even value, which would still be even. So then all of this would be even value, and this would be even value, and therefore you could not have an even number being doubled, because that would lead to an odd value. So this has to be an odd value, and it has to be non-doubled. So this is not doubled, and it has to be an odd value, and it has to have 1, 2, 3, 4, 5 other values less than it. One of which could be doubled. Well, it still has 5 values, though. And therefore, that's 5 digits that are less than it. So it cannot be 5. It has to be 7 or 9 here. Doubled. Or, sorry. It's not doubled. Specifically not doubled. So then, what could this be, essentially, is the question, right? So, 3 times 9 is 27. Even if you have 8 doubled, that only adds up to 16 for these digits. So 16 plus 27 is 43, which is less than what a full box should add up to in normal Sudoku. So even without the doubler, that doesn't work. Therefore, this has to be the doubler. Because otherwise, we tried it with 8, and that doesn't work. So therefore, this has to be something else doubled. So none of these can be doubled. None of these can be doubled. That's actually very important. And none of these can be doubled. None of these can be doubled here, because this is the doubler. And what could it be? Well, obviously it has to be an even number doubled. But if you get 2 and 4 doubled, that's still 8 or less, which is obviously not going to add up to greater than 45. So this has to be 6 or 8 doubled. If you have 8 doubled, that's 16. And say you had well, if you have 8 doubled, that would be 16, and these two doubled values would have to add up to it, and the only non-doubled values you could have is 7 and 9, which would eliminate all possibilities for that cell. So this cannot be 8 doubled. This has to be a 6 doubled. These are okay, so therefore this is 6 doubled. That's 12. 12 plus 7 times 3 would be 43. So this cannot work. Wait, that doesn't work either. Hold up. Um, Even if you have 6 doubled with 9 times 3. Oh, wait, yeah, no, that's correct, I think. So say that's 6. This is 12 in value, plus another 12. So this is 24. And the total value is what, 51? Yeah, 45 plus 6, which is 51. So 51 minus 24 is 9, I believe. 9 times 3. 51 minus 6 doubled times 2, so that's 24, is 27, and that's 3 times 9. So this is 9. This then has to add up to 12 here. So, and it cannot be 3, 9. It could be 4, 8 or 5, 7. We're not sure which. This is 6. These are not doubled. And of the non-doubled, you can either have 7, 8, 9 or 6, 8, 9 as the digits. Well, it can't be 6, so this must be 7, 8, and 9. So this can't be 7 or 8. This can't be 4 or 5. This cannot be 6, 7, 8, or 9. So this has to have a 1 doubled here. Oh, no, sorry, this is 3 doubled here. Because it's 24 times 2, which is 48, minus 45, which is 3. The rest of these are 1, 2, 3, 4, 5. This obviously cannot be 5, because this is at most 5 here. This is 3, 4, or 5, and the 5 cannot be doubled. So this cannot be 5 here, because the 5 in the circle could only be if the 5 was doubled, right? So this is specifically a 3 or 4, which means one of these is 1, and then we have the other being 2 or 3. So this cannot be 1 here. This is 3 or 4. The 3 or 4 has to be with the 7 doubled specifically, and an 8 or a 9. So this is the 7 being doubled. So one of these is the double, which means these can't be doubled, and these can't be doubled. This cannot be 7. Cannot be 7 here. The other one, well, that can't be specifically be 7. One of these is doubled. We're not sure which. This can't be 9. This is 4, 5, a 7, or 8. This also, so this has to be either 1, 3, 5, or 2, 3, 4, adding up to 9. So the rest, so it's either a 4 or 5 in one of these 3 sets. It also has a 3. So this cannot be 3, and it cannot be 4, 5, because again, one of these 3 is a 4, 5. This has to be a 4, 5. That eliminates 4 and 5 from the rest of the box. So this can't be 3, 4, or 5. This is 1 or 2. 1 or 2 has to be with 7 or 8 to add up to 9. So therefore, we have a 7, 8, 7, 8 pair in row 2, which eliminates 7 and 8 in the rest of the row, which means this can't be 7 or 8. This has to be a 9. So this is a 9, which makes this the 7 doubled. So this is 9, and this has to be, so again, this is 7 doubled, which means the total box adds up to 45 plus 7, which is 52. The arrows in value must be essentially 2 times the value in the arrow in the circles must equal the total one, which is 52. So 52 divided by 2 is 26. 26 minus 7, sorry, 26 minus 14 is 12, minus 9 is 3. So this is 3, which forces this to be, that's 3 in the corner, Therefore, this has to be 1 and 2. This can't be 2 or 3. This is 4 or 5, which means this is 4 or 5, adding up to 9. Excuse me. Which means the remaining digits are 6 and 8. So this is 6 and 8 here. We also know this cannot be doubled. So one of these is doubled, and it has to have a 3. So the 3 has to be doubled here. This can't be 3 or 9. And it can no longer have a 3 or 4 in the rest of these cells. One of these is 6, 8, or 9. We're not sure which. And the other one is a 5 doubled. Well, anyways, we see in here that we have a 5, 6, 7, 8, 9 quintuplet in row 6. So the rest of the row is 1 through 4. This is 1 through 4. This is 6 or 8. This cannot be a 3. The remaining digits here are 3, 6, and we have 1 out of 1, 2, 4, 5. We're not sure which. And these have to be 1 through 5. The 3 is doubled. So we don't have a 3 and a 6 adding. We don't have a 3 in value. So the 7 and the 8 in value must be 1, 2, 3, and 6. Right? Because it has to be 1, 6, and 2, 6. Because it does not have a 3 anymore available. And you don't have access to 1, 7, so the 8 has to be specifically 2 in the value of 6. The 7 has to be 1 in the value of 6 because it doesn't have a 3 remaining. And therefore, the 9 has to be a 4 and a 5, but we're not sure which one's which. So the 3 and the 6 are both here. So 1 and 2 cannot be here because that would force the 3 and the 6 to be here. So this can't be 3. And this cannot be 1 or 2. So 1 of 4, 5 is here. That means 1 of 4, 5 is here. Well, we have a 4, 5 being here and a 4, 5 being here. Therefore, this cannot be 4, 5. Therefore, this is 1, 2. We have a 1, 2, 1, 2 pair in the box, which eliminates 1 and 2 in the rest of the box. So this is 3, 4, 5. If this were 6, 8, and 9, this would have to be 5 and 7. And the 5 would be doubled. But this is not allowed to be doubled. So this cannot be 6, 8, 9 here. This has to be the 5 being doubled here, which means none of these can be doubled. None of these can be doubled. None of these can be doubled. And this has to be, so this is a 5 doubled, which means none of these can be 5. Therefore, this has to be 6, 8, and 9. Without the 6, 8, and 9 being doubled. And the 1 is doubled. So this cannot be 1 because this can't be doubled. So 1 is one of these 3. 1 has to be one of these doubled, but we're not sure which. And we have a 5 doubled, and it's either 6, 9 or 7, 8. Well, it cannot be 6, 9 because that would force both of these cells to be 8, which is not allowed by normal Sudoku. So this has to be 5, 7, 8 here, which means this can't be 8. This has to be 6, which makes this a 9. Therefore, this is an 8. And we have a 5, 7, 8 doubled. The 5 is doubled. And the 7 or 8 are not doubled, so the 5 doubled has to add up with 1 to add up to 9. Okay. That means the 7 has to be 2, 6 or 3, 5. Cannot be 3, 5, so it's 2, 6. So we have 1, 9, 2, 6, and the 8 adds up with Wait, that doesn't work. Huh. Is that not correct then? No, the 7 has to be 3 and 4. Right. It's 2 and 5 to add up to 7. I don't know why I got 2 and 6. Okay, I was thinking of 8, but it was actually 7. Um, right. So 5 doubled has to add up with 1 and 9. The 7 has to be 3 and 4 because 2 and 5 is no longer allowed, and 1 is taken by the 1 and 6. And then the 8 is 2 and 6 specifically. Okay, so that works. The 8 cannot add up with 4 to add up to anything. Actually, could it? Well, the 1 is doubled here, so that's a 2 in value. So we have a 2 and a 3 possible. But this is specifically 2 or 3, which means this has to be 5 or 6 to add up to 8. But it can't be 6, so this must be 3 and 5, and this is not doubled. The 6 has to be 2 in value in a 4, but it still could be either of these. And the 9 is a 2 in value with a 7, and this can't be 7, so this must be the 7, which means this has to be 2. Oops. This is 2. This has to be the 1, which is doubled. Therefore, this can't be doubled anymore, and these can't be doubled. This has to be 4 to add up to 6. Therefore, the 1 cannot be here, which means the 1 has to be one of these. That means the 9 has to be one of these 3. Okay, so then let's see the corresponding one. So this is 9. This is 1. That means this has to be 2, because none of these can be 2. So the 2, again, adds up with the 6 to add up to 8. So one of these is 6. And then we have 3 and 4. And this can't be 4, so this must be 4, which makes this a 3. So this is 1, 2, 3. Adding 3 adds up to the 4 to add up to 7. 2 and 6 add up to 8, and 1 and 9 add up to the 5 doubled. Remaining digits here are 3, 5, and 7. Remaining digits here, so this can't be 3 anymore. This is a 1, 2, 4 triplet, which means the remaining digits here are 6, 8, and 9. This can't be 6 or 9 here, so this must be in 8, which means this is 6 or 9. But the 6 cannot be doubled here, so the 9 has to be the doubled one here. But we don't know which one it is. So we've got a 1 doubled, a 3 doubled, a 5 doubled, a 6 and a 7 doubled, a 9 doubled. So this is specifically a 2, 4, or an 8 doubled here. 8 cannot be doubled here. So this is 2 or 4 doubled. And this is 2, 4, 8 doubled. We're not sure which, though. Okay. This is 2, 4, or 8 doubled. I don't think this can be doubled, right? Well, we have... This, again, the total value of this box must be an odd digit, because it cannot be 9, and it can't be 1, 3, 5, 7 doubled. So 2, 4, or 6 is doubled, so the total has to be odd. This is 4 times a number. These digits plus 4 times this digit is equal to these 4 cells. So these digits, so This is 4 times. So 4 times this digit plus these remaining 4 digits add up to these 4 digits, right? We know that an even digit is doubled, so the total value must be an odd value. If we take an odd digit here, that would mean that the rest of the box would be even in value, because you subtract an odd from an odd value, which is 45, you get an even value. So then 4 times an odd value would make this all even, but we know that the odd value is doubled. Or sorry, an even value is doubled, so therefore the entire box must be odd. So if this cannot be an odd digit then. This has to be an even digit. So it's 2, 4, 6, and 8. That's interesting. Can it ever be doubled? Even if you have 2 doubled. Hmm. Hmm. So if you have a 2 doubled, that gives you a value of 47 for the box. If you have a 4 doubled, it's 49. 6 doubled is 51. And 8 doubled, okay, can't be 6 doubled. 8 doubled is 53. And you have 4 digits that add up to that. Huh. This can't be 8 because of this 8, so this must be a 6, which makes this an 8. So this has to be 3 with 1, 2, 4, or 5. Oh, this can't be... Well, there you go. That's other things. This can't be 1, so this must be 2, which makes this a 1. That means this can't be 2, so this is 1, which makes that 8. So this is 7, and these two add up to 12, so this is 5, which makes that 4, which makes that 5. This can't be 1, so this is 2. These can't be 5 here, so this is 3 and 4. This can no longer be 5, so this is a 3, 4, 6 triplet in the box, which eliminates 1, 3, 4, and 6 from the rest of the box. This can't be 4. So one of these is 3, 4, 6. One of these is 1, 2, 5. This can't be 1. This can't be 7. This can't be 5. The remaining digits here are 2, 3, and 7. Well, 3 and 7 already have doubles in them, and one of these 3 must be the remaining doubles, so this must be 2 doubled. So the remaining doubles now are 4 and 8 in box 7 and 8. So this is 4, 8 doubled. This is 4 or 8 doubled. We're not sure. Okay. So that means this value is either 49 or 53. Therefore, this cannot be 8. If this is 8, that's 32. And then 32 plus... Yeah, it's... Oh, that's actually... Very... Huh. This value is essentially quadrupled. So that means it has to be the value of 8 doubled. If that's the case. Does that work? I don't know. So, okay, the value of this as a total is... Wait. Okay, I'm thinking about it all wrong. That's not how you should be thinking about it. Obviously this still has to be even though, right? Because if you take an odd there, the rest of these digits have to be even. Is that right? Hmm. I'm not sure if my logic there was correct. Okay, so let's go through the logic again. What happens if we have this being an odd digit? Even say it's 1. So 1 is the easiest one, right? That means you could have something like 3, 2. Uh, you would have to have 4 doubled or 8 doubled, but 8 double is not 1 away from anything. So you would have to have 4 doubled. So if you had 1, 2, you could have 2, 3 somewhere. You would have to have 5, 6 together, and 7, 8, and then 4 doubled with 9. And actually, I think that works, right? Yeah, okay, so that logic that I previously had is not correct. Okay. Yeah, so good thing I double checked on that. Okay. What digits can be here then, is the question. Well, each of these 4 values has to be essentially that difference away from these 4 values. Okay, and we know an even value is doubled. It has to be 4 or 8. So, if it's 8 doubled, that means you have a 16 in value. But the closest you could have from that would be a 7 away from 9. And no other values are 7 away from each other from if you remove 7, 8, and 9. So the 8 cannot be doubled here. So it has to be 4 doubled somewhere, which means you have 2 8s. So you have the values 1, 2, 3, 5, 6, 7, 8, 8, and 9. Well, the problem is any other value have 4 you have doubled. If you have an 8, you have an 8. If you try to make it a difference of 2 or more, they all have to go to the same digit, right? So if you have a value of 8 and another value of 8, and you try to take 2 away from that, or try to add 2 away, you have 10 in value, but you've already used your double in the 8, in the 4 being doubled. So therefore, if you try to use it with an 8, with 2 or more in value, you have 6 or 10. And the 10 obviously doesn't work, so they would both have to be 6, which doesn't work. So therefore, the difference does have to be 1 for each of these. So this has to be 1, which means this can't be 1. This cannot be 1, which means this can't be 9, because this can't, so this can't add up to 5. So this is not double. This can't be 1. And, well, we don't know what this is. So the 1 is not doubled. So we know this is not doubled. We have 2 and 3 going together, 5 and 6 going together. So the 2 is one of the 2 is one of these. Let's remove that coloring. 2 is one of these, which means 3 has to be the corresponding one here. You have 5 and 6 together. So you have 5 and then 6 And then the problem is 4, 7, 8, and 9 can be any of them. Okay. Because 4, 7, and 8 are essentially a pair. And then... But that's 7 and 8 in value. So 7 could be with a 4. Oh, wait. 7 can never be in a circle. So 7 can't be in a circle. Um... 7 has to be one of these. And 9 can never be on an arrow. So this can't be 9. Okay. If this is 9, this would have to be 8. Which would mean this is 7. So if this is 9, this would be 8. This would be 7. Which would force this to be 1 and either 3 doubled or 6. But this would be 7. And this would have to be 5 doubled, which would require a 1 and 9 adding up to it. But this was 7 with 1 and 6, so this couldn't be a 1, which would break that. So this cannot be 9, which means this cannot be 8. Because the 8 would have to be with a 7 doubled. Or sorry, with a 7 singular. And therefore it would be this would have to be 8 if that were the case. If this was 8 and this was 7, this would be 5 doubled, which would make this 1 and 9. But then this would have to be, well, okay, that could work. So if this is 8, this is 7, this is 5 doubled. That's a 9. So this is 4, 5, which would make this 1 and 9. That would be 6 here then. If this is 9, this would be 8. Or I guess it could be 4 doubled. Okay, so, this still could be 8. This could be 9. Ooh. If this could be 9 and 4 doubled, I forgot about that. Oof. If this is 9 and 4 doubled, though, that's interesting. Okay, so what are the possibilities? We tried 9 and 8. That doesn't work because that forces this to be 7, which makes this 1 with either 3 doubled or 6. This 7, well, can be 3 doubled, so it would be 1 and 6 because this would have to be 5 doubled, which would mean that's 1 and 9, but we have a 1 in both of these cells, which is not allowed. So this cannot be 9 and 8. What about 9 and 4 doubled? If this is 9 and 4 doubled, that means none of these can be doubled. So this would be 7 or 8, and this would be 7 or 8. Well, either way, this would be 6. So since this is 6, this would be 4, which would mean 4 and 3 add up together. So therefore, this would be 7. This would be 8. 8 would be 2 and 6. So again, you'd have 9 singular, 4 doubled. This would have to be 7 or 8, 7 or 8. This is a 6. This would therefore be 4. This would be 3. That would make this 7. This would have to be 8. This would have to be... What would this be? This would be 2 and 6. This is 1. This is 7. And this would have to be 5, which is not allowed. Because 5 is never on the circle. So we've shown 9 cannot be in this circle at all. Also, 8 can't be here then. Actually, 4 doubled can't be here either, because they can only be where the 9 on the arrow where 9 is in the circle. And this can't be 9 anymore. So this can't be 4 or 8. Okay. What about this? Well, obviously this can't be 9 and 8 because that would eliminate all possibilities for, or it would eliminate 2 possibilities for these cells, and therefore this would be 7 and 7, which is a contradiction in normal Sudoku rules. So 9 and 8 doesn't work here, so this cannot be 8 here. What about 9 and double 4? Maybe. So this would be 9, this would be double 4. Which would mean this is a 7-8, 7-8 pair. This cannot be 4, 8, or 9. So this is 3 and 6, which would force this to be 2 and 5. 7 or 8, 7 or 8. This cannot be 9 anymore. So this cannot be 4 and 5. So it has to be 2 here. Oh, actually, maybe that's what we should be targeting. Anyways, we've gone through this one already. This one can't be 8. Because if this is 8, this has to be a 9. This is 2 or 5. 2 can only be with 3 or 6 to add up to 3 doubled or 6 to add up to 8. And 5 can only be with 4 to add up to 9. So this can't be 7. That's another reason why this can't be 9 and 8. If this is 9 and 4 doubled, that makes this an 8, which forces this to be 7. This cannot be 4, 8, or 9. It's 3 and 6. This can't be 4 or 9. So therefore, this has to be 6. 6 and 2 add up to 8. So this would be 2 and 8. This would be 3, so that would 4, that would be 2. This would be 3, this would be 1, 9, 4. This can't be 3, 4, or 6, so we would have a contradiction here. Okay, so no. So this can't be 7. This cannot be 9. So this cannot be 9 here. Because we tried it with a 4 doubled. So 4 doubled cannot be here either. Because it would have to be on an arrow with 9 in the circle. So this can't be 4. If this is 9 and this is 8, that seems like it's possible. Oh, obviously this can't be 8 here. If this is 8, this is 7, and that would eliminate all possibilities for that cell. So this can't be 8. This could still be 4 doubled, though that's interesting. What if we tried to make it 4 doubled? If this is 4 doubled, this is 7. This is 8, this is 9. Therefore, this would be 4. Oh, and 5. So this cannot be 4 doubled then here. Okay, well, there you go. So this can't be 4 doubled, which means this can never be 7. So this is either 3 or 6, and it has to have a 2 or 5 next to it. So this can't be 7. So neither of these are doubled. So either this is doubled, which is a doubled 4, or this is doubled, which is a doubled 3. So this can never be 4 then. If this was 4, again, you cannot have, okay, so either these are not doubled, right? Because it's specifically 3 and 6 here, right? And we know the 4 is doubled in this box. None of these are doubled because the 5 has to be doubled and it's not here. This could be doubled or this could be doubled, specifically in column 1. If this is doubled, it's a 4 doubled, which means this can't be 4. If this is doubled, it's a 3 doubled, which means the 4 can't be there either. So this cannot be 4 here either way. Well, we have a 3-6 pair now in column 1, which eliminates 3 and 6 from the rest of the column. Also, actually, let's go this way. Let's do it this way. Since this can't be 4 anymore, this can't add up with a 5 to add up to 9. So this has to be 8 no matter what. So this is 8, which means these can't be 8. This has to be a 2, and this has to be a value of 6 no matter what. So this can't be 6, this can't be, this can't be 2, this can't be 2. This is a value of 6 no matter what. This is an 8, which means this can't be 8, so this must be 7, which means it's 3 and 4 added together. This can't be 2, and this can't be 2. This can't be 3, so this is not doubled, because the 3 is doubled in that box, remember? This can't be 4, so this can't be 4, which means this can't be 5, which means this is a 1 with the 3 or 6 doubled. This cannot be 1, so this is 5, this is 4, this is 9, this is 7. 7 cannot be either of these two. These can't be 4, and these can't be 3. This can't be 1 anymore, so this must be 2. 2 and 6 must add up to 8, and therefore this is a 5, which is doubled. So this is not doubled. This has to be 1 and 9 then, which means this cannot be 8 or 9. This can't be 5 or 4, and this can't be 5 or 4. So one of these is a 7, the other one's an 8. Well, if this was 8, the problem is it's not, it doesn't add up to 9 here. So this cannot be 8, this has to be 7, which forces this to be the 4 doubled. So this is the doubled, which means none of these are doubled. None of these are doubled, and this is not doubled. So this is the double, which makes this a 3. This is a 6. This must be a 3, which forces this to be a 2. This is an 8, which forces this to be a 9. This cannot be 2 or 7, so this is 5, which forces this to be 6. This cannot be 2, because it's not doubled. This can't be 2, from just in general. So this is a 3-7 pair in column 7, which eliminates 3 and 7 in the rest of the column. So this must be 2, and it must be 2 doubled, because that's the only digit that can be doubled and remaining in that box. Okay, what else do we have? This can't be 2. Remaining digits here are 1, 5, and 8. This can't be 5, this can't be 1, this can't be 8. Remaining digits here are 4, 6, and 9. And this can't be 4, this can't be 6, and this can't be 9. We know the 8 is doubled. And it cannot be here, it cannot be here, it must be here. Because this is the only place possible to be doubled left. So this is doubled. Which means these can't be doubled and this can't be doubled. Which means this is doubled and is the 9. So therefore this is 6. This can't be 8, so this is 5, which makes that 1, which makes that 8. This can't be 7, so this is 3, this is 7. Remaining digits in row 8 are 4, 3, and 9. And neither of this can be 9. So it's specifically 3 and 4, and this can't be 4, so this is 9, which makes that 6, which makes that 4. We have a 3, 4, 3, 4 pair in column 5, which eliminates 3 and 4 in the rest of the column. This can't be 3, so it's 7. This can't be 4. And the remaining digits in column 5 are 1, 2, and 6. Well, this can't be 6, so therefore this must be 6 here. And this is 1 or 2. We also have 1, 2, and 9 in the rest of row 7. This can't be 9, this can't be 9, so this must be a 9, which forces this to be 1 or 2, but this can't be 2 because of that 2, so this is 1, which makes that 2, which makes that 1, that makes that 4, which makes that 2. This 4 means this can't be 4, so this is 3, 4, that makes this 3 and 4. This cannot be 3 or 7, so this is 5, which makes that 3. And we finish the rest with Sudoku. That's a 5, and this is the 7. And that's how you solve it. Pretty cool, actually. I like this adding up of things, right? And it was very interesting, particularly with this part of the break-in. Um, yeah, it was basically that this had to be an odd digit, and this had to be the even digit, an even digit doubled, with a value greater than 8. And it couldn't be 8 doubled. So that led to a certain thing, right? Because this would have to be 7 or 9. That was very cool, actually. This whole break-in right here. And this logic actually was really interesting, too. Really, the whole puzzle was actually really brilliant. Really cool use of the arrows to limit things. Which essentially had, I guess it's not really a break-in, because it was basically just limited things. But it limited things in a very specific extent, right? Really cool puzzle. Ichtus or Ichutes. I don't know how to pronounce the name. Apologies for that. But anyways, I hope you enjoyed this solve of this puzzle, and I'll see you next time on Frank Puzzles. Take care.